Good evening to everyone. I hope you all are fine. I am back again with few other actuating methods of soft robots. Yesterday we have discussed magnetic actuating soft robots, electrically induced ion migration soft robots, dielectric elastomer based soft robots, and the diagram representation of these soft robots. I hope you understood yesterday's lecture. So today we will discuss some new other kind of actuating soft robots. So topics to be discussed in this video. Firstly, we will discuss electrochromic soft robots. Secondly, we will discuss piezoelectrical soft robots. Next, we have cable or tendon actuating soft robots. Then we will discuss pneumatic actuating soft robots. In the end, we have hydraulic actuating soft robots. So these robots we will discuss today. Clear? So number one is electrochromic soft robots. So chromic means the change in the color by applying electricity. So in nature, you have seen that some creatures can change their color instantly and their texture as well as their posture to adapt to the situation. Like you have seen chameleons or octopus vulgaris and cuttlefish. They can change their color or texture according to the situations. Next, the soft robots also can achieve these color changing shape or texture when an electrical stimulus is applied to them. Clear? In the presence of electrical stimulus, the robots are designed to change their colors. Next. For example, one example is given here that researchers have fabricated an all-transparent electrochromic supercapacitor device. It is capable of changing its color when an electrical stimulus is given to it. And the name of the device is electrochromic supercapacitor device. Then they also reported an air working electrochromic artificial muscles which are known as EAMs, and these EAMs are capable of deforming themselves. Deformation means they can elongate, they can stretch themselves. They means the soft robots can contract themselves by changing color. When like we can say the soft robot is having gray color, and if we change the color to blue, then it contracts or it elongates. It deforms itself when the color is changed. Clear? Then one example is given that EAMs generated a value is given of contractile stroke and it is around 12%. Clear? And the color changes are from yellow to green and gray, and the voltage is applied under plus minus 4 volt. Clear? Secondly, we have piezoelectrical soft robots. I hope you understood electrochromic soft robots. Now, the second one is piezoelectrical soft robots. So, we know that vibration is the fastest motion we can observe in nature, like the motion of the strings, motion of the honeybees. These motions are motions of vibration, and we can observe it in a very fastest way. So, the soft robots, scientists or researchers got the idea that some kind of vibrations we can make soft robots by taking the concept of vibration. So they made soft robots and they worked by vibrations, and these soft robots have attracted the attention of so many scientists and researchers because of their response time and the output they have shown. Next we have the researchers reported a bionic piezoelectrical soft robot. Clear? And it is made up of inverse piezoelectric actuated PVDF film, which consists of Ag means silver electrodes and a passive layer of copper. Clear? Copper is an element and the passive layer is formed of copper element, and the maximum moving speed you can say the 42.8 body lengths per second BL per S, and the velocity you can say 482 degree per second. Clear? And when the applied voltage was 200. So one more researcher was there who presented a fast moving and ultra robust soft robot, and it was based on a curved unimorph piezoelectrical structure. Unimorph means it can be moved only in a single way, and that consisted of a PVDF layer and having electrodes of two elements, that is palladium and gold, and it consists of adhesive silicone and PET substrate. Clear? So piezoelectrical soft robots work on vibrations, and the soft robots changes their structure on the basis of vibration only. Understood? Next we have the soft robot based on large vibration amplitude, and it was the easiest way to generate a wavy motion, because when the vibrations are produced, the soft robots could generate a wavy motion which is near to its resonant frequency. It's done. Next we have cable or tendon actuating soft robots. That means the soft robots are formed with the help of cables or tendons. So the cable or tendon actuated soft robots uses cable, and the cable embedded in the soft construction means when we make the robots, we use cable inside it with having two ends, with one end fixed at one specific position, and the first end is controlled by the other end, and the other end controls it to contract or expand, that means to move the structure. One end is fixed, the second end controls the first end to contract and expand the structure and move accordingly. So it uses cables. So based on this mechanism, they have described a cable driven soft figure. The researchers took this as a base, and they have derived a cable driven soft figure, and this soft finger has the ability to move quickly and to bend accordingly when the supply is given, and perform basic hand movements. Like cables are there inside the soft robots, they can bend, they can move, they can move their hands, like if it wants to grasp a tomato, so it can do with the help of cable tendon actuating soft robots. Next, they have also prepared a soft actuator with a free sliding SMA wires, and SMA wires are not anything else, they are just tendons, and their maximum weight of the target was only 1.5 kg. Understood? Not more than that. Next we have pneumatic actuating soft robots. So they work on filling the gas into the soft structure of soft robots. Means pneumatic actuating soft robots fill the gas inside its structure through different kinds of airways, and this will create uneven pressure into the structure, and it will help in achieving different kinds of motion trajectories. That if the soft robots want to move in a particular direction and then to the other, then trajectory is finalized, and the trajectory is made according to the uneven pressure in the structure. Like you have seen earthworms, and the researchers are inspired by earthworms after seeing the motion, after seeing the uh, motions carried out by the earthworm. The researchers have presented a pneumatically driven soft robot, and this robot could move in two directions, horizontal as well as inclined platforms. The motion nodes can be adjusted through the robot, and the frictional coefficient were under the controlled inflation or deflation arrangements. Understood? It works on by creating the uneven pressure inside the structure by filling the gas inside the structure. Next we have another scientist came. He proposed a type of pneumatical soft robot that could move in a pipe. So one researcher came and he made a pneumatical soft robot, and it was capable of moving in a pipe. Then one researcher presented the micro scale soft pneumatic actuators, that are SPA, and they have different working patterns according to the structures. Understood? Last we have hydraulic actuating soft robots. So compared to the pneumatical actuators in which air are filled inside the structure, the hydraulically responsive soft robots work under, as the name suggests, it works under hydraulic pressure. Hydraulic pressure means the pressure of water. So these actuators, these soft robots work under the pressure of water. And one example is given that researchers have designed a hydraulic soft actuators, and the soft actuators having the 3 hydraulic chambers, and they could complete the spatial movement mean movement in the space like extending, contracting, bending, steering, moving in a one direction. So these movements they can make. Next we have, so these are the projects they have made. One more researcher presented 3 underwater soft actuators, and namely they were water hydraulic soft grippers and a water hydraulic soft biomimetic fishtail. Next we have, they also presented an untethered soft robotic fish. One robotic fish they have made, and the robotic fish has the ability to record the daily life of aquatic organisms. Okay, and the robotic fish works on the hydraulic actuating soft robot. Okay, and the velocity and the turn controlled by the tail propulsion frequency and deflection under the hydraulic pressure. Clear? The velocity and the turn of robotic fish is controlled by the tail propulsion frequency. Next we have some combining the characteristics of air pressure as well as hydraulic pressure. That means pneumatic, you can say pneumatic actuating soft robots or hydraulic actuating soft robots. So this is the scientists have prepared a hybrid actuated soft robots, which is a combination of pneumatic actuating soft robots as well as the hydraulic actuating soft robots. So the robot, the combined robot, the combination of these two soft robots, they could swim as well as crawl in the water, in the oceans, to carry out the information of the following aquatic, about the daily life of the aquatic organism. So it would be beneficial for the researchers if they want to know what kind of activities, what is the daily routine of the aquatic organisms, different types of aquatic organism, what do they do, how do they breathe, how do they means inhale the gas. So these types of activities they could get. Next, so this is the complete video of today, and I will be back with some more videos. Till then, stay tuned to my YouTube channel, and please don't forget to like, share and subscribe. I'll be back again. Thank you. Have a nice day.